Good morning friends, welcome back. In the last video, we discussed about the basic of the drainage system. In continuation of that, this is the part 2 video and today we are going to see one of the important thing in the drainage system, that is the pipe sizing. So in regards to pipe sizing, we have plenty of methods to do the sizing like international plumbing code we can follow uniform plumbing code or we can follow the British standard. In this video, I am going to highlight how to do the pipe sizing using the British standard because that is normally followed in the GCC countries like Qatar, UAE, etc. So when it comes to British standard, the important standard we are following for the sizing is the BSEN 12056, which has total 5 sections, part 1, 2, 3, 4, 5. Part 1 related to the general requirements related to the drainage system, and part 2 is for the sanitary pipework layout and calculation. So this part 2 we will use for the pipe sizing of the sanitary system. Coming to the part 3, it is related to the drainage, like roof drainage layout and calculation. Part 4 is for the wastewater lifting plan, and part 5 is for the installation and testing. So that is mainly for the installation, testing, maintenance and use. So now we will start the pipe sizing using the part 2. Before going to the part 2, we need to understand first of all what are the system this standard defines. So we have total 4 kind of system 1, 2, 3, 4. System 1 is a type of approach we are using like a German, Swiss, Austrian type practice. System 2 is normally we are using for the Norway, Sweden, Denmark, Finland, Iceland, this kind of thing. System 3 is the UK practice. System 4 is the French practice. So what makes the things different is the system 1, first of all, this is a single stack system. Not only system 1, system 2 single stack, system 3 also single stack system. Then what makes the thing different is the filling. How much filling the pipe carries, that is the important thing, filling degree. So when it comes to system 1, the filling degree is only 50%. For example, if you see in the top view, you have a toilet like this, you have a wash basin. So this wash basin discharge the water to a flow trap. From this flow trap, this one discharge the water to the vertical stack. This is the top view. So what is the water filling degree we have from this horizontal pipeline, I mean the horizontal pipeline, that is called as a filling degree. If you say 50% filling degree, only 50% water will be there, remaining 50% air will be there. When it comes to system 2, in this system it is a 70% filling degree, like 70% water will be there, the balance will be the air filled. Coming to the third one, it is 100% filling degree we have, that is normally followed for the UK practice. When it comes to French practice, it's not about the filling degree, it's about the arrangement. As I told you earlier, system 1, 2, 3, it follows the single stack system. For the waste and soil, there will be only one riser pipe, vertical pipe. All the waste and soil water will be dropped to the single riser. But when it comes to system 4, that is the French practice, we have two riser or two stack for the waste stack and for the soil stack. So there are two kind of stack system available for the French practice. Now coming to the different, so system 1, as I told, is only the partly filled branch, that is only 50% filling degree. So you would use the larger branch pipe, example 50 mm for the wash basin. So the wash basin, the half of the pipes are water filled, half of the pipes are air trapped. So when the wash basin discharge, the pipe is only half full, so 20 mm water depth and in the 50 mm pipe. So advantage of this system is air always flow above the water. It prevents self siphonage. That's what I told you last class also. This is related to the negative pressure created during the pushing of the water closer, during the pressing of the water closer, like that. So we have to avoid this one in the system. So this is the one of the positive advantage of this system. But you know that moving forward with this one, it will increase the cost. So this is one of the biggest drawback we need to consider for the system 1. Coming to the system 2, we would use a small branch like 32 to 40 mm, normally 40 mm for the system 2, that is a 70% filling degree we are following. This is the most common size we actually use, 40 mm for the wash basin. Then coming to system 3, it is a full bore branch, that like a 100% filling degree. That means for the wash basin you need to use a 32 mm pipe, so all the 32 mm we consider as a almost fully filled. So this is the three different of system 1, 2, 3. Coming to system 4, the main thing is they are not talking about the filling degree. System 4 is not for the filling degree. They are talking about the arrangements. They are just talking about the arrangements only. So when it comes to arrangement, you have two stack. One is for the water closet, urinal, all the black water, you have one stock. Another one is for the gray water. You have the wash basins, kitchen sink, bathtub, bidet, all this one. This is going with the gray water. So the filling degree of the branch pipe in the system 4 will still follow the design rule of the system 1 or 2 or 3. So either these three you can select, but how you make the arrangement, that make the things different. Okay, now we will have an example for the understanding. So in this, okay, what's practically normally followed, that is we need to understand. So we also separate a soil stock and waste stock like a double stock system. The whole system in our projects are normally system 4. We normally follow this type of approach in the high rise, super rise building, all this kind of thing. We will have a separate stocks. So it's a system with the system 4 arrangement with system 2 style branch piping. So system 2 is what? It's a 50% filling. So we will go with the system 4 arrangement, but the filling degree is 50%, that we will follow. So this is like a combined approach. So we are following a hybrid system of system 4 plus system 3, not system 3. So this is the like a combination of system we are normally following for the pipe sizing. So this is the practical thing we need to understand first. Now, when it comes to the drainage system, these 5 things are the very important thing we will call as a saga. What is saga? The S is the size, A is the airtight, G is the gradient, how much slope we have to provide, A is the access door we have to provide, and finally the acoustic, the soundproof. So first, today we are going to see the pipe sizing. Pipes will be large enough to carry anticipated discharge to avoid any overflooding and other issue. So when it goes to pipe sizing, we need to have the drainage fixer unit. This is one of the key term used in the drainage and water supply piping. In the water supply piping, it is the water supply fixer unit. In the drainage, it is the drainage fixer unit. So in the drainage fixer unit, I have given here some appliance, sanitary fixer appliance like wash basin, bidet, shower, then urinal, then like a bath, then kitchen sink, dishwasher, washing machine, water closets, floor gully, this type of arrangements. Let's say we have this. Hello friends, 1 minute. We work hard to collect all the information from various sources to give you best understanding of the subject. Most of the people watch the video but they don't subscribe. Please motivate us by subscribing our channel to post more and more technical videos for you. Thank you. System 1, 2, 3, 4, 4 systems are there. There are some numbers they have given. So the confusion will come to you like what is this number and how these numbers are derived. So I have a detailed explanation for you to understand. First, the discharge unit is what? It's not the actual flow rate. So if someone say the wash basin discharge unit is 0.5, that is not equal to 0.5 liter per second. Okay, then what is that actually? Instead, it is the probabilistic value. It's a probability. First of all, the overall the plumbing system is depends on the probability, same like a firefighting, not like a HVAC system. For example, if you have a if you have a bathroom, toilet room, you have a wash basin, you have a water closet, you have a bathtub, you have a bidet. If a person enter into the toilet room, he cannot or he will not use all the fixer all together in a time. He cannot use all the fixer all together in a single time. So that's the reason we are going with the probability. So this is the drainage system is completely based on the probability design. So the value in the BSCN 12056 is not random. They are based on maximum flow rate, frequency of use, and appliance storage or discharge pattern. So how much water can come out at once, that is the maximum flow rate. How often people actually use it, that is the frequency of use. And third thing is the storage. Water closet has a cistern, so it will discharge suddenly, it will create a big impact, while a wash basin discharge more slowly. So this also plays an important role. So the standard committee CEN or TC 1665 studied the usage for the different building, residential, commercial, hospital, hotels and everything. They are giving the weighting system, that is called as a discharge unit. For example, if you say a kitchen sink, so in the kitchen sink, a kitchen sink tap may have a flow rate of 0.1 to 0.2 liter per second if half open. If fully is open, then 0.53 to 0.5 liter per second. So sinks are used quite often. We are using frequently, but usually not left on at full bore for a long periods. We are not going to use for a long periods. with the full bore. Okay, so considering the average duration, frequency, and simultaneously how simultaneously we are using, the standard committee we give the weight of 0.8 drainage unit. That is not the flow rate, that is the standard weighting factor from the standard committee. So 0.8, if you say, that is the statistical equivalent of value of what impact it creates. But when it comes to vast basin, it will be 0.5 fixed unit. Why? Flow rate is usually less than the kitchen sink. Usage is frequent, but for a shorter period, like a wash basin, hand washing, a small shorter period we are using. Because of the lower volume of the duration, it is given a smaller load, 0.5 compared with the 0.8 of the kitchen sink. Now we have a formula to size the pipe sizing. That is means the stock sizing. That is Q is equal to K into sum of the discharge unit. So here we have the frequency factor. As I told, the plumbing system and firefighting system is design is based on the probability. So here they have given the frequency factor. If you use the intermediate, if you have intermediate usage like the office building, guest house, you can go with a very low frequency factor of 0.5. Then for the hospital, school, restaurant, you need to use 0.7. For the toilet shower which is open to public, you have to go with 1. Then for the laboratory, you have to go to the 1.2. That is a special case. Okay, so now for the theaters, stadium, this type of thing is a congested type. So that time you will use the public, open to public, that is with the 1. So Q is the flow rate, F is the frequency factor which is coming from here, and delta U is the, sorry, DU is sum of the fixed units coming from the last table which I showed you. Now we have a project called the stadium project. In that stadium project, we have 56 liter water closet. If you see here, 6 liter water closet. I'm going to use the single just for example, I'm going to use the single stack system with the UK practice. So this project you can assume like if it is from the UK, so it is like 100% filling degree, and we are going to use the single stack. So we have 100 watt wash basin, so we am going to choose this 0.3 to here. So 50 into 1.7, 100 into 0.3, you sum with both, you will get 115 fixer unit. Now I need to take the root, because the formula is the root of du. So 115 root is 10.7. And for the frequency factor, this is the congested use stadium open to the public, so we will use the 1. So 1 multiply with this one, 10.7, you will get 10.7 liter per second. 10.7 liter per second. So using the 10.7 liter per second, you can see this stock pipe size for the system 1, 2, 3, 4. Here we have two category. One is the square entry, one is the swept entry. I am going to explain very detailed when to use what and what is not recommended, what is recommended, and for which fittings, horizontal discharge, vertical discharge. All we are going to see in the coming class in a very detailed way. Don't worry about that. So for time being, you can say swept entries. We will square entries is very less case, so we will go with swept entries. That means till 12.4 we can use the 10.7 liter per second of pipelines. Okay, so we can go with the 150 mm dia stock piping, stock sizing for these applications. Now we have completed the pipe sizing. We have some airtight, watertight, and there are plenty of rules are there. We are going to discuss very detail about the rules for the super high rise and high rise building. What is velocity breaker? How much floor once we need to use the velocity breaker? Grease trap. There are plenty of things are there. We will discuss one by one in the coming parts. So thank you for watching the video. Please like, share, and comment. See you again. Thank you.